Hi, welcome. I will talk about updating firmware on Linux with the FWUPD. I am Daniel. I am a system software engineer at Framework. That means I write anything, any sort of code related to the product. I am from Germany and I live in Taiwan 4 years already. Yes, I work for Framework Computer, firmware there now. We make computers that you own, that you pay the money, so you own it, you can do whatever you want with it. You can repair it. We sell you the replacement parts. You can run any software, any OS you want. Officially we support Windows and Linux right now. And some of the firmware you can modify, like the embedded controller and the keyboard firmware. You can build your own and replace it. And some of the modules you can build yourself. We open much documentation that a lot of the community has built their own keyboard or an enclosure for the camera or things like this. And we also try to be sustainable. Right? Repairing already helps that, and we use a lot of recycled material in the production. These are our main two products right now, the 13-inch laptop, and we have a 16-inch version, which is even more modular. Yeah. I'm of course presenting from the laptop here. Oops. Yeah, like I said, it's very modular, so we have already released a lot of upgrades. If you have bought the laptop 4 years ago, you can buy now, this year we have a new screen that is higher resolution, higher frame rate, a higher capacity battery, better speakers, stronger hinges, like if you hold it like this, that it's more sturdy. Whoops. Yeah. And mainboards. We have already 5 different mainboards with new CPU generations, Intel and AMD. You can use whatever you want and upgrade. You don't have to throw away the whole laptop. Okay, what is firmware? Maybe not everybody knows. Firmware is basically just software that is installed at the factory. Even if you do buy it without operating system, there's still code in the product. What does it do? It basically just turns on your system and makes the hardware work. For example, an analogy like the body is that software is your brain. It tells you what you want to do. It actually does useful things. And the firmware is like your neural system. It keeps you alive. It makes you breathe, beats your heart, pumps your blood. Like in the laptop, the firmware makes sure the battery is charged. This is what it looks like if you open it up, and the main firmware people always know is the BIOS, and it's stored here in the BIOS flash. But actually there's a lot more firmware. If you turn it around, you see there are a lot of chips, which is pretty complicated, but we have 4 retimers, 2 PD controllers, and an embedded controller, and everything runs software. Everything has firmware, and all of this is code, so it needs to get updated. It has bugs, and we can improve it. Yeah, BIOS, EC, PD controller, retimer, and then on Intel you have the ME, CSME. And that's not the end. Also the modules like the fingerprint reader, the camera, SD, everything has firmware. So there's a lot to do. But why do you want to update firmware? The biggest reason is, of course, if there's new hardware, you might need to adjust the code to support it. Like when we release the higher capacity battery, the voltage is different, so we need to adjust the code to handle the difference. Or we have new features, like in the beginning you couldn't set the battery charge limit, but now you can say I want to stop charging at 90%, and that keeps your battery healthier for longer. Bug fixes, of course. Like USB-C is very complicated. We always find some devices that are not compatible. Security fixes, very important. Usually they come from the open source EDK2 that we base our firmware on. And then performance improvement, that's also what users like. New firmware sometimes improves the battery life. But firmware updates are very annoying. Usually legacy firmware updaters They're very strange programs. They look strange. They don't look very trustworthy, or they are Windows only, and you don't have the code to them. You don't know what they do. And how do you know if you're up to date or when there's a new update? Usually you need to go to the manufacturer's website, or maybe they have an email subscription list, but it's not very easy. And yeah, because the programs are so weird, it's risky and scary. If a firmware update goes wrong, in the worst case, your device is trash. It's bricked. All of these things firmware update daemon can help with. It's a clean command line with a couple of GUIs that build on top of it, and it runs on Linux and is portable to other operating systems like the BSD family. And it's open source, so you can see what it does. You can trust it. It can show you the current version that you have, and it can show you updates or previous updates that you maybe want to revert to, and it automatically downloads the latest information to show you that there's a new update available. And optionally, if your update has succeeded or failed, you can upload a report to us so that we know everything's good or if there's a problem. Yeah, it's built from two components. The daemon that runs on your operating system. It's open source software, and it fetches the updates from the server, and it applies them to your system. It gets those updates from the LVFS, the Linux Vendor Firmware Service, which is just a server that distributes the files. That we as a manufacturer, we upload the updates to, and then your daemon downloads them. The command line looks like this. You can just say what devices you have, it tells you what version, and if there's an update or not. You can probably run it on your device if you have Linux, and it will tell you some output, even if there are no updates available, if your vendor does not support them. If you like a graphical user interface, it looks like this. You see all of the different devices that are supported. For example, our new camera, you can update the firmware, or I can reinstall the old firmware, or downgrade to a previous version. Right, so us as a manufacturer, how do we add support for a new device, like the new camera? The daemon already has a lot of plugins, so most devices already have a plugin. If not, then you make a new one. So we have already contributed a lot of changes to adjust existing plugins or create new plugins. Often if there's already a plugin, you just need to add a quirk file, just like to add our ID, and then it's supported. And then we create an XML file that describes the device and the firmware. And this looks like this. Of course, you don't have to look at the details, but you can look later if you want to refer to my slides. But it's not very complicated, just the description, the version, and the file, and release notes. And on the bottom here, I can say that at least you have to be on this previous version, because of firmware updates, you need to go to an intermediate version, and then you can go to the next one. You can't update from a super old one. Then, once you created the XML, you just bundle it into a cab file. What's the time? And this cab file, you can upload, well, not you, but we as a manufacturer, we upload it to the LVFS. And LVFS distributes the files, but also us, it gives some analysis, like it checks for common security problems. And so we can find issues even before our users download and install it. Yeah, if there's something wrong with the XML or we need to adjust something, we can still do it in the user interface there. And once it's ready, we click the release button, to release it to our embargo channel, and then we can test it on our devices internally. And yeah, they have these 4 channels. First is embargo, which means everybody in our company can test it. If it's ready, we move it to testing, and anybody who has the update daemon can opt into it. They can say, I want to have testing updates, and they get like beta versions of the updates. So we can test it on a larger scale, and if we get the reports back and see everything is good, we move it to stable. Basically everybody running Linux will get the update, because all modern distributions, they have it integrated. This is the web interface that you as a user don't have access to, but we can see our firmware. And some interesting tabs are requires. Like I said, here we can adjust which firmware version you need to have at least, or maybe it depends on a different component's firmware version. Yeah. So even afterwards we can adjust it if we notice there's some problem and we need to restrict it even more. Shards is really interesting. LVFS analyzes our firmware and looks at the components inside. So it's very technical, so I won't go into detail, but it's gives us insight into what's exactly in the firmware. Certificates is very interesting, because maybe you've heard about the security incident recently that a lot of vendors released firmware with testing certificates that should not be used in production. And I don't know how that happened, but we're not affected. And they would have seen it here on certificates. It shows you which certificates are expired or which are testing certificates. Yeah. Right, we at Framework we already have 33 updates for 15 devices, and they have been downloaded almost 40,000 times. Yeah, that means not everybody has updated their firmware, and if you have a system, please go update. Our most popular one is the most recent laptop, which the latest BIOS was downloaded over 12,000 times. Just on Linux. But our Windows users, they use a different mechanism. Not as easy. Yeah, like I said, LVFS, it shows some analysis of all firmware we update. Like it automatically runs Binali's FW hunt, which can even detect vulnerabilities that are not known yet. It has some AI to guess new vulnerabilities. Yeah, certificates, and it even does antivirus scanning. And like I mentioned, users can optionally send a report to let us know if the firmware update has failed or not. And it's very privacy respecting, so it does not include much information, just a little bit that can sometimes help us debug it and let us know if the firmware is bad. If it's failing on a lot of systems, we'll pull the update. But it hasn't happened to us yet. So you can see this is what it looks like for us. You can see that 100% success rate, 94% success rate, 93%. The failures are probably because, I don't know, something has happened with the power, like the power situation. Maybe the user has pulled a power plug or unstable power, I don't know. It also reports the user agent, like in the web browser, but in this case it means it reports the version of firmware update daemon and the distribution that it runs on. So this gives us better insight into what users are running than surveys, because it actually tells us what people are running. Only if they update their firmware though. So maybe people of some distribution are more likely to update their firmware than others. So it's still, we have to take caution here. I included 2 diagrams here, and on one Ubuntu is first, on the other Fedora is first. So yeah, it just gives us a basic picture and overview. That's it, yeah. So the conclusion is firmware updates used to be scary, but they're pretty easy now. Firmware update daemon is great, and yeah, it's the year of Linux on the laptop. Do we have a second microphone for questions?
Sorry, came in so late. So what's still yet to be done in FWUPD? I mean, if you had infinite resources, where are the holes in the development? Can't be a big project, right?
Well, in general, support for hardware. We have support for almost everything. Let me think if something's missing. Sometimes things are missing because we don't have control over everything of the hardware. Like if we make we have an Ethernet expansion card, and the chip is made by Realtek, and they make the firmware. We don't have control over that. So when they provide an update, they say, oh, here, use this Windows program. But we can't make a plugin for this. So recently, more and more vendors have started to contribute to this. And it's on us and other OEMs to push those vendors to contribute more plugins.
Does it work well in Monsoon and RISC-V and other types of architectures?
Right. The BIOS updates, UEFI updates, they work on UEFI-based systems. On ARM or on RISC-V, often you don't have UEFI, so you have to adjust it to how you update the firmware there. You could probably use flash ROM or something else, but it depends on the system.
I have a question about how you track the K2 vulnerabilities. FWUPD added like SBOM, so you could say like this UEFI image is based on this K2. Do you use that with FWUPD? And if not, how do shards work for what you're tracking?
We are working on SBOM support, but we usually get this for free through the binary scan. So even though we don't have the information encoded directly, sometimes we do it ourselves. We go and add which vulnerabilities are affected, because we already know it before uploading it. And then if you run your FWD command, it will show you this firmware is affected by these vulnerabilities. Yeah, SBOM is something that is coming. Yeah, but usually we're already aware.